Let's step back and talk about jumps. The try form that we just added is one way that a program can jump out to an enclosing context. So here in this try, when we go to evaluate the body expression, we're in the middle of an addition, 2 plus 3 plus, and then we have an error. So at that point with the error, we jump out to the catch handler, and then we resume the addition. Just before we execute the try, we have this 1 plus hole. When we go to evaluate the try and we reach the catch handler, we jump back out and places the value 0 into that hole. Even before we had try, we had another kind of a jump, because errors by themselves will jump out. Wherever we are in a program, once we hit an error, we jump back out to the very top of the program. Let's look now at a more general form of jump. This one comes from Shplait. It's called letscc. And this form gives a name to the current context and lets a program jump out to it at any time. So here we have 1 plus letscc k1. K1 gives a name to the current continuation. Then we go to evaluate the letscc body. 2 plus letscc k2. Okay, so now we have a name for a second continuation. And then inside here we have 4 plus k1 of 5. At the k1 of 5 call, we jump back out to 1 plus hole because that was the continuation at the point when k1 was bound. And the value that we jump with is the argument that we supplied to k1, the value 5. If we change this program so that now we jump to the k2 continuation, then what our context looks like, k2, that's 1 plus 2 plus hole. And so we swap in 5 for the hole, and the whole result is 5 plus 2 plus 1. Let's run this in Shplait. So here we have the first program where we're jumping out to k1. So when we run this, we expect to see 5 plus 1. And yes, we got a 6. So now if we change this to k2, we should see 5 plus 2 plus 1, yes, 8. And if we wrap the whole thing in a letscc escape, and instead of k2, we call escape, then we should jump all the way to the top with the 5. And yes, we have just 5. So that's jumping out. Now, does it ever make sense to jump into a continuation? Yes, it does make sense to jump in. We just need to give a name to that continuation that we want to jump to. And for that, the easiest way to go is mutation. So here we define a mutable variable. Its name is continue, and it's going to be a function. Right now, it's a placeholder identity function. Then we bind the current continuation to the name escape. And then we have 1 plus 2 plus 3 plus 4 plus letscc for the next continuation. And inside this block, we bind continue to k. So now our mutable variable has a new value, and it's the k right here. And then we escape up to 0. So at this point, we don't do any addition for 1 plus 2 plus 3 plus 4. Escape jumps out to the top of this letscc. And now that we're back at the top, we call continue with 5. So that jumps back into the continuation k. And the result of this program is the sum 1 plus 2 plus 3 plus 4 plus the 5 that we swapped into the hole. Here's another way to look at it. When we do letscc of k, that bubble there is what k is bound to. That's the continuation. So the hole there comes at the end of the addition. This k is a function, so we can write the continuation slightly differently as a function that takes in some value, and then whenever we call k, we pass in the value for where v is. And that way, continue is bound to a function that takes in a v and does that summation. We can run this program in Shplait too. So here it is, define mutable continue, letscc escape, and we call continue with 5. And there are two results here, 0 and 15. 0 is the result from this letscc because we did escape with 0. And then 15 is the result of continue with 5. So that's 5 plus 4, 3, 2, 1.